We've got a customer joining us, PHYTEC, who is an advanced electronics developer and manufacturer. They focus on this thing called SOM, System on Modules. And Serah's joined us. Serah's the leader for this particular project. And she came to us with a problem. And that problem was, we've got this great circuit architecture that solves some problems for our customers. Specifically, this is an EV charger. But the problem is our customers aren't connecting with these circuit boards that we have to offer. So we need to develop a housing for this device that looks like a charger, and we need it as soon as possible. So obviously, additive manufacturing swooped in, saved the day, and Serah's going to share that journey with us, talking to us, sharing with us about PHYTEC, the types of solutions that they offer, the markets they serve, and then ultimately her journey in learning about additive manufacturing and how the technology helped solve her problem in the case of this circuit architecture business.
You took something that we were making that was kind of a little outside of our area of expertise. We're all electrical engineers, hardware and software, layout, manufacturing. So we're very deep in electronics. And then you guys were able to help us elevate it by providing design services and making it for us.
So this housing was designed in-house to be produced from HP multi-jet fusion using nylon 12. Once the housing was printed, we vapor smoothed it and then finally added heat-staked inserts so that the components can be assembled as a system. The initial production was of one unit to test fit everything, and then from there we produced an additional set of units, and the whole design was intended to be produced in low volume. So we're conscientious of the installation process, designed for additive manufacturing and production. We were looking at this from a low volume production standpoint. And because it was vapor smoothed and in the hands of customers, we also dyed the housing so that it would look like an injection molded, high quality, high surface finish device.
Project we brought today, we made an EV charging reference design.
So this is Gen 1. This is a solution you were using before we supported you on the project.
Yeah, so we called this Rev 0. Our product is so far inside, we wanted to be able to see it. So we did a clear case. So we showcased this EV charger reference design at Embedded World. This was a successful product. And this enclosure, this Rev 0 enclosure, to go show customers reference design, see it in action, we were shipping it. And that thing is heavy. It's like acrylic, it's big. The box we have to ship it in is like oversized, just about fits the shipping limits. A little difficult internationally to get ready for a couple other shows and to have a reference design to work with customers with so they can really visualize what our reference design is. I found DI Labs. So even our first conversation, I think I sent you this picture and just said, can you make this look like an EV charger, please?
As you approached us, you shared with us, I think the nickname of this is the fish tank.
Yeah, we call it the fish tank, yeah.
When we first talked about your project, discussed it, it's like we design all these cool electronics inside that make all this magic happen. And this fish tank design allows us to show off our electronics. But what we're trying to accomplish is we want our clients to envision what the product could look like if they were going to make it themselves. And as you're deeply ingrained in the embedded systems and you don't have the resources available to your team for the design and development of the case, that's where we connected. It's like, wow, yeah, this is a perfect match where we can support you on something that you're not able to do in-house today. And, the electronic side's like, we're not developing electronics. So it was a great kickoff right from the beginning.
Yeah, and I think that the real thing we were trying to solve too was we wanted to turn this demo into a fleet of EV chargers as well. So we needed more of them and very fast. So I remember my first conversation was, hi, we have this. I need it redesigned, and I need 5 of them in 5 days. Tell me I'm crazy. And your guy Alex wouldn't refuse to tell me I was crazy. And I was like, I know that this is unreal. This is not even realistic. Make a design from scratch and print it and make me like 5, just in print time. But you guys came really dang close. Like, got me a prototype in 2 weeks from just the first contact. And I think that's really the key. You guys really delivered on. I don't know if you dropped everything you were doing to work on this, or I don't know what the magic was, but yeah, maybe you can even tell us.
And as we're acting with, our day-to-day focus is new product development, especially when it comes to developing, physical product for assembly or parts or look and feel, whatever it may be. We're accustomed to the ambiguous request of, we need this thing and we don't know what it needs to be, but can you make it for us? Can you make it for us fast? Because that's really important for our project. So we went through our standard new product development process, and we have industrial designer on our team. So first step is, what is this thing going to look like? Because the person who designs the functionality of a product isn't the person who's going to design what it looks like, because those are counterproductive in most cases. So we made some sketches. So he said, to us, this is what an EV charger should look like. I think we shared the sketches with you.
Yeah, you did. Yeah. I think we immediately were like, oh, yeah. But I can see it even has ports on the bottom, too. I think in your initial sketches, too, you guys were telling us, like, hey, we need to plan for how your power is going to come in, because you can't just be having drill holes in the side, hack it up kind of for your demo and whatnot. So I thought that was really nice.
And so we did a little translating from your request to what you were really asking for. And it's something that's a significant challenge on product development, because it's like, from one point of view, there's a request coming from that perspective. And then we're trying to convert that request and translate it into what's really required. What are they really asking for? They're asking for it based on their known perspective, and then it's like, we've got to convert that into what's actually possible, so that we're not limiting them with their perspective, but we're going to enable them with what's possible.
Yeah, I remember even on a call one time, you're like, well, we need to do a cable clamp. And I was like, cable clamp? And I like Googled it, and I was like, oh, okay.
Those pesky cable glands.
Or cable gland, that's what it was. It was a cable gland. And I think I remember it because I'm like, oh, it kind of like clamps the cable in there. But yeah, I had to look that up. So you don't know what you don't know. You guys introduced us to quite a lot of things. I felt like I was giving you an impossible task, but like never once was there any sweat. You guys are like, no problem, we can do it. And then the speed at which you ripped out this drawing, I was shocked. Like, I think it was within 3 days I had a drawing, and the timeline started to be a little realistic. So it was like a week of just kind of going back and forth on the design, which you brought in an industrial designer even. Like, I don't even know how you guys fit the time in. And then the next week, I think you were printing.
First week felt really slow as we were getting the requirements from you. And then we're going back and forth, like, how do you want to assemble the electronics within the device? And how do you want to stack them so you have access to the things that are critical? But it's also easy for you to do, because, once we get this to you, you've got to get everything together, and then you've got to get it to the show, and it's got to work. And there's really no opportunity to have a failure here and still meet the timeline. So that first week, it felt really slow, but being very planful and collaborating through that process, it made it really easy for us. So you brought the information, and then we were able to collaborate in real time, make sure our electronics were located right, we could assemble it, and for us, it went pretty smooth.
Yeah, so the housing is really designed to hold and mount the internal components and be able to do so that it's easily assemblable. And then for teardown, it can be easily torn down. So it was designed as if it's a final good, even recognizing it's a prototype. And being able to work with your team and understanding the constraints that you have and the objectives you had for each of the boards, the spacing, the panel, allowed us to really tailor the design specifically for your needs. And not in all cases are the projects that well defined initially. So as much as it looked like it happened really fast and there was a lot of magic happening, the collaboration that we had between our team and your team was really critical for that to be successful. And just understanding all those details that clearly you and the PHYTEC team had lined out really, really well. So that appreciated the level of detail that the team had, and that's what helped make this thing successful for sure.
Yeah, I mean, I feel like we had a good handle on the problem.
Yeah.
We just we didn't know what our solution was. So that's where you guys really completed the project for us.
The final design that we sent you for Rev 1, it's on the right side. We assembled all the parts before we shipped it, so we knew that it was going to work, everything fit, and it's kind of like a training piece. It's like, okay, this is how parts go together, because they've never seen this before. We just saw it for the first time 15 minutes ago. So we're going to send it to you assembled so that you don't have to figure out how to get all these parts together.
I mean, it worked out great that way too, because when we got it, picture, take the first layer out, picture. I'm a visual person. Most of the engineers I work with are visual, and they want something that
Looks and feels.
Yeah, that's part of the experience, right? Yeah. It's all about experience. I think that having your guys' case and your expertise levels up the experience, makes it a better experience when you're working with it, so that you can really tear down and see what you want to make. It gets you one big step closer to where you actually want to go. So when you go into a meeting, you're trying to pitch the product, you have something you can show. And something that maybe people that aren't engineers can understand, and gives you like a platform that you can look at.
It's really powerful, I think, the idea that in order to really bridge the gap for customers with things like this, it's important that they have the ability to look and feel and interact with a device that looks like it's finished, and then that connects the dots for them. Probably the first time that we've experienced that level of bridge building from something as instrumental but small in the big picture as this. You know what I mean? So really cool.
We're engineers, we build bridges, right?
Yeah, that's exactly right.
You guys really nailed it, and everyone's just been really excited about the work that you do, so